Well, I want to welcome all of you to today's session on advanced manufacturing. I'm not used to using paper, so I will try and not drop it and get confused as I go. But today, in this room, we're going to focus on automation and additive manufacturing, including a look at supply chain and Industry 5.0. This should be useful. Our goal here is to create useful information that you can take back with you where you go. My name is Eric Miller. I'm the co-owner of a company called Additive. I'm an engineer by training and an entrepreneur by happenstance. I also write and speak a lot on both business and technology in a lot of different venues. Our company, Additive, does simulation, product development, and 3D printing. And full disclosure, we're a reseller for ANSYS Flownex for simulation, and for Stratasys, EOS, and GOM/Zeiss for the hardware side of things. So I do have biases in those areas. So let's get started with a little bit of show of hands. So first thing I want to know is how many of you here, this is your first show since COVID started? Yeah, so a lot of you. Yeah, this show last year was my first show during that lull before it came back. So how many of you do some sort of advanced manufacturing or manage an advanced manufacturing team? Anybody? Okay. So how many of you are vendors in the advanced manufacturing space? All right. Good. Well, I guess us. We can all raise our hand. And that, so you're all, the rest of you, all of you, I assume, are here to learn about advanced manufacturing and where things are going and where they are. So we want to thank you for coming. A little bit about the session, and I've been involved in what we used to call computer-aided engineering since I graduated, actually while I was in college back in the Stone Age when it was on an IBM mainframe. That shows you how long ago it was. You know, it's changed. You know, all aspects of computer-driven engineering has changed a lot, but right now, I feel like manufacturing is seeing the most rapid and significant change and having the biggest impact on things. Now, things like smart machines and agile production shells and 3D printing and, you know, advanced automation, you know, these were things for most of my career that, you know, special teams did. You know, there was always a methods team that kind of did it in the corner, and they would, you know, come up with some great ideas and then they never go anywhere, generally speaking, or they would be like one cell. What's changed is what the problem was is that labor costs, you know, we went international, right? And so low labor costs overseas kind of made this advanced manufacturing not cost effective. You could just get it done cheaper with low labor costs. Well, that's changing, right? Low labor costs aren't there anymore. Those countries that were cheap aren't so much anymore. I don't have to tell you guys about supply chain and disruption and COVID and war and stuff like that. So, you know, a lot of companies are saying, hey, let's take a look again on reshoring. And how are we going to reshore? We're going to do it through advanced manufacturing. You know, it's been a real change that I've seen, and I think we'll talk a little bit about in the panel that everybody's seen, where companies are really looking to using advanced manufacturing to reduce the cost, increase the quality, and bring it local again. So let's dig into it. Have an open two-way conversation. I'll reach out for questions when everybody's done speaking. Let's move beyond the buzzwords as much as we like to use them and talk about practical applications and new processes, systems, and software to make this new manufacturing revolution a reality. So for our panel today, we're going to be talking about the promise of additive manufacturing for production. And Yale and I discussed this and, you know, what's new, what's happening, what's the big trend in additive. And for me, what I'm most excited about is finally, after 30 some years of being in this business, we're starting to make production parts in additive manufacturing. And it's not just a few applications, it's growing and wider. It's not just Invisalign, that was always the one we pointed to for decades. It's everywhere, right? And we want to talk about that and share the experience and where it's going and where it's at. So we've got a great panel to do that. I'll give a little bit of bios here. Tim Heller joins us from Stratasys. He's a seasoned veteran of the additive manufacturing industry, beginning back when it was called rapid prototyping. I remember that, in 1988. Having joined Stratasys in 93, Tim has helped companies around the world adopt stereolithography, FDM and PolyJet, and most recently, in 2015, began the go-to-market for high-throughput powder bed fusion in the Americas for Hewlett-Packard, or HP, before a brief retirement. And then fortunately, I don't know why, he decided to rejoin us at Stratasys in 2020 and lead the commercial activity for the Stratasys SAF, which is an amazing powder bed machine that we just love at PADT in the Americas. And then from Velo 3D, we have Matt Koresh. And so he's a technical sales engineer at Velo. He started his career in backup power generation before moving to commercial aviation, where he worked on high-pressure turbine blade design. I did as well. Matt started working with additive manufacturing in 2017. He's experienced in several disciplines, including laser powder bed fusion, electron beam melting, and binder jetting. He holds a mechanical engineering degree from the Georgia Institute of Technology. And then Sam Rubin is joining us from Mighty Buildings. He's an accomplished innovator, entrepreneur, executive, chief sustainability and partnership officer, and co-founder of Mighty Buildings, a well-funded $70 million plus construction company based out of Oakland, California, which is using 3D printing technology, new composite materials, and robotics to manufacture houses. His passion and deep understanding of sustainability and compliance drew him to the vision of addressing the housing affordability crisis by 3D printing sustainable homes and communities. As part of Mighty Builders' founding team, Sam has leveraged his expertise working with organizations of all sizes across public, private, and nonprofit sectors to help them improve the sustainability in terms of people, planet, and profit to guide Mighty Buildings' certification and sustainability roadmaps. This has resulted in Mighty Buildings producing the first UL-listed 3D printed building components, being the first company certified under UL 3401, the new standard for 3D printing and construction, and the first housing unit utilizing 3D printing components to be certified at the state level in California. So bringing his expertise to Mighty Buildings alongside his other team members, Sam is indeed working to make the world a better place. And then we also have Matt Sand from 3DEO. Matt is passionate about making differences through innovation and entrepreneurship. His expertise primarily lies with early stage business formulation and technology product development. Thanks to breadth of entrepreneurial experience, he has a unique perspective on how to build a successful startup. Since receiving his MBA, Matt has played operational roles across the entrepreneurial ecosystem. He has invested in early stage companies, co-founded several entrepreneurial ventures, and taught entrepreneurship courses at UCLA and LMU. Consulted with a variety of early stage companies and co-authored the Agile Startup book published by Wiley & Sons. So I think that is everybody. I got everybody in this. Good. So let's go ahead and shuffle my papers and look for my questions. So, I think where I want to really do is start by having each of you share where your organization is in terms of providing production parts using additive manufacturing. That's our thing. So we'll just go ahead and start here and work our way across. So where are you as far as production?
Hey, Matt Sand with 3DO, and all we do is production. Actually, we invented a new technology. It's a bind and sinter type of technology. We invented it specifically for serial production. When we founded the company back in 2016, we saw that the prototyping market was well served, that low volume, high value applications were pretty well served, but there was a conspicuous absence of any wins in mass production. And being the masochistic entrepreneurs that we were, we said that's what we wanted to do. And so we started by inventing a printer, and very quickly we realized that the printer was only maybe 20% of the battle when it comes to mass production. So we kind of incorporated the full factory scope, and we decided to not sell printers, but instead to sell parts. So we're a parts supplier using our proprietary technology. We're right here in Torrance, California.
This is going to be really hard not to dive deep into each of these, but we'll come back and talk about the challenges you faced. So go ahead.
Am I on? Good morning, everybody. I'm Tim Heller, and glad to see everybody COVIDly spaced. That's very good. Not even asking. So I'm with Stratasys, and as that really beautiful introduction, which I may have written, says, I've been with them for quite a long time and dealt with a lot of technologies. But what's interesting is over the time that I spent at Stratasys, and I was also at HP, I've been able to watch an industry go from, let's call it analog to digital, right? It started with rapid prototyping. It took us forever to convince people that it was a good value play, and then they wanted better parts, and the parts sucked, right? They weren't all that good. But they were so valuable in a low volume, high value situation, as a prototype would be, right? It's so labor intensive to make a prototype 30 years ago, right? Without 3D printing. So wow, they'll buy a $250,000 machine just to make this one little part that doesn't do anything. That was a transformation. And then we had other moments of transformation, like for me, when Stratasys realized it actually had a pretty accurate technology, which nobody gave us much credit for, we said, oh, we maybe can do some more industrial things than just prototypes. So we started doing low volume, high value jigs and fixtures, indirect manufacturing. So what kind of cut to the current, and you heard that I had been retired, and Stratasys contacted me and said, hey, we have this opportunity for this role. And I thought, wow, there's kind of two really exciting things about coming out of retirement to join Stratasys. What was it? This time we get to do another analog to digital transformation, at least for Stratasys, to move into volumes, where low volume, high value is no longer the required term in front of our products. It's now volume. So I'm dealing with powder bed fusion, which Stratasys is new at, but it has the latest technology in terms of a wide area powder bed fusion, right? Or some people refer to it in the category of high-speed sintering. We also have Origin, which is a DOP technology, but for the first time, well, not first time, there are competitors out there, but for the first time for Stratasys, we were able to, in both technologies, bring a volume play. So it's no longer tens and hundreds, which we could do end-use parts in FDM, tens and hundreds. But now we're talking about tens of thousands or maybe hundreds of thousands in a technology. This is new for Stratasys. This excites me a lot personally, because this is the first time where we can really move Stratasys into the production world of higher volumes. But then, and I'll pass the mic now, but my parting thought with this is, as I think about additive and Stratasys play, additive doesn't change supply chain. It's a miracle, it's cool, additive, but it's only a piece of that advanced manufacturing puzzle. And now when you do volumes, we run into other problems. And that is labor now has become an issue again, because we make so many parts that we need labor to clean the parts. So now we need automation and stuff. And I hear that in the room, I see it downstairs and stuff like that. So that's me in a nutshell.
Sam Rubin with Mighty Buildings. So we're doing things a little differently, given that we're in the construction space, but even within that, we're pretty unique. Because not only are we doing 3D printing, but we're doing prefabrication, and we're not using concrete. So we've actually developed a proprietary printing material and production process. So it's a UV curable thermoset composite. It starts as kind of a gel. So it's a combination of UV curable plus extrusion. And we also incorporate continuous fiber reinforcement into that process as well. So we end up with 3D printed wall panels that have the strength profile of reinforced concrete, but 4 times less weight, 4 times better insulation. And also, one of the cool things is, because we're doing prefab, we combine it with post-processing. So we're not just doing the print and then we have to do everything manually on site. We actually utilize a robotic post-processing system for quality control with 3D scanning to go along with thermography that we have incorporated into the printing process itself. But also our materials, even though it's really strong, it's still soft enough that we can mill it with CNC heads normally used for metals. So that means that not only can we create unique forms with the printing process, we can then create unique facade looks with the milling process. And that also allows us to do spray coating, stucco, paints, primers, as well as pouring insulation into the interior cavities of the panels to increase the energy efficiency. So we're kind of doing things pretty unique in that regard. But one of the things we're really trying to address is the lack of productivity in the construction sector. It's really the last major industry that has yet to embrace efficiencies and new technologies in order to achieve its goals. I think, and there's a report from like 2017 by McKinsey, it's something like $1.7 trillion are being left on the table every single year globally due to lack of productivity. Additionally, that's leading to a housing crisis where by 2025, 1 in 3 urban dwellers are going to be facing housing scarcity, 1.6 billion people globally. So it's a big problem. And on top of that, we're dealing with the reality that 40% of all global emissions and GHG are tied to the built environment, 30% from the operation, and then another 10% from the actual construction. So it's really, how do we begin to leverage this technology to address that housing crisis, but do so in a way that doesn't add to that, the climate crisis. So we're addressing both with a carbon neutrality roadmap and really optimizing our materials, looking at things like incorporating biochar and other sequestration. But at the end of the day, we're trying to achieve about 80% automation. So we're not trying to go lights out like that. We've looked across industries and realized that's I mean, that almost killed Tesla, trying to go lights out on the Model 3. So what we're really trying to do is focus the human parts on the where it makes sense, while also attracting new generation of workers. And to achieve that, we're developing a microfactory concept where in a 50 by 50 square foot footprint, we can generate enough panels for 100 homes a year. and we can deploy that into existing warehouse space near where there's demand, near where we have builder partners, to have a distributed production network that allows us to reduce costs, take advantage of local supply chains, local economics, as well as also create local jobs. So it's really about how do we leverage automation to create distributed production to solve some of these big intractable problems.
Very cool. And as long as you get rid of the horizontal lines in that are in the concrete houses, I'll be happy.
Well, right now we're leaving them just because that's customers tell us they like it. But that's the nice thing about what we're doing is we don't have to have it.
As a 3D printing guy, I just hate it.
Oh yeah. No, I look at the concrete ones and I look at some of the promo photos and some of these concrete ones. I'm like, holy shit, you let that out. You're proud of that? I'm like, God, that wouldn't pass quality control.
I've been trying to get rid of those for 30 years.
Yeah, exactly.
Speaking of which, perfect segue for Velo 3D, getting rid of those stair steps.
Yeah, so Matt Karish with Velo 3D, and I think similar to the other Matt, we focus very much on production. So we do laser powder bed fusion. We say we sell a solution, not just a printer. And I think we had the advantage of starting a little bit after a lot of the other major metal AM companies. And so we got to kind of leapfrog all their learnings and challenges that they had. So we saw a lot of the issues out there with, I'll say, non-repeatability and kind of snowflake machines where each one needed to be treated differently. And so we went to address a lot of that and figure out how do we make these machines behave the same, not only like at a single site, but regardless of where they're located, regardless of who's running them. And then how do we make sure that the parts that are coming off of them are the same? So can you create one build file and send it across the world and get the same part again across the world? And so it's what we quickly realized is it's not just a hardware solution. Hardware is kind of the way you make the part, but to be able to do all the things I just mentioned, you need to have very good control with your software and your process parameters and your process monitoring, and then also being able to report out kind of from a quality control perspective, all the things that were happening during your build so you can tell if something went wrong. So kind of took this, I think, semiconductor industry approach to additive manufacturing. Our founder came from the semiconductor industry, so put a ton of metrology into our equipment, and I think kind of got lucky in our timing and where we started. And so a lot of people, when you hear Velo 3D out there, you hear a lot about the flashy, bright type of geometric freedoms, things we can do. So very low angles without requiring support structure, which is neat and an enabling feature. I think other people will catch up to that eventually, but from my perspective and my experiences, the bigger value that we're bringing to the AM industry today is that repeatability, that scalability, that process control and process monitoring that enables true production, not only on like single machine, but even a distributed supply chain, if you will.
Hey, Eric, can I comment on something?
Yes.
So, I guess I was gonna anyway, but so
No.
you mentioned the layer like layer lines, and I think it's kind of funny, just a perspective of how does manufacturing happen and how does additive take part, right? We're all in the additive biz, and you think about it, when you do the analog to digital transformations, you ask people to think differently, right? But we're trained to think one way, and then we live for years, and I've lived more years than I should. But anyway, here I am through all these years thinking, this is what I want. This is what I want. I want this to be smooth. I want this to look like this. But each time, each generation, as we've gone through these analog to digital transformations, we've taken another step to people being open to a different expectation. So right now you buy something and you're expecting smooth. Let me give an example. So you buy a car, maybe a bit of a high-end car, and you buy the moldings, right? You choose your moldings. It could be wood grain or it could be leather or whatever. And what's one of the ones that's selected a lot, at least, I don't know, maybe not now, but in the last 10 to 15 years? Composite look, right? Carbon fiber. I can guarantee you the first carbon fiber interlaced or woven fabric, people say, oh, that surface finish is horrible. We need something smooth, right? We can't have that. And so they fought it, and now all of a sudden I'm paying extra money to put that exact surface in my car. Think about that. So going back to additive, years ago, I sold an FDM, or a partner sold an FDM, and I got to meet this customer, and they made custom chairs. They think Captain Kirk, right? But on oil rigs. So for big oil rigs in the North Sea or whatever, they made these chairs. They cost huge amounts of money, right? More than first class seats on an airplane. They're a huge amount of money. So this customer bought a couple of Stratasys FDM machines, and they put them in a closet, more or less, and that was their production room. And they were making these little, probably black polycarbonate or something. And of course, there are layer lines in Stratasys and FDM, right? So they put them in. Somebody asked a question in a conference. They said, but what about the surface finish? You're using that as end-use parts? They said, yeah, we're not going to change a thing because our customers think that that's pretty exotic to have a 3D printed layer line thing right at their fingertips. It's expectation. So now put our hats on. You're all here because you're probably thinking forward, how can we go into some sort of additive flow or embrace some of the newer technologies that surround additive maybe. Think about what happens in 40 years, right? I'll be gone, or at least retired. But the things that are going to happen and be accepted then for the trade-offs that we give them is going to be totally different. And that's where we're marching to. So I just want to comment on layer lines and what they really mean.
Yeah, well, and on the housing side, it's a look that people actually are willing to pay a lot to have done by hand currently. And we're like, and so there's already that aesthetic appreciation for it. But yeah, it's that flexibility that really, I think, is one of the things that's going to allow us to move forward, though, is that ability to create different looks and really meet those variety of needs and aesthetics.
It's a really good point. It's a really good point. So one of the things that came up while we were going through where you guys are is challenges. So I know that it wasn't easy to get to production. So let's go ahead and start with you, Matt. What was the biggest challenge you guys faced in getting production?
Assume that's Velo, Matt.
Yeah. I'm sorry. Sorry, Matt too.
Currently still facing. It's like, which one do you pick? I think there's a couple different ways you can look at it. I think if I look at where we are today, it's kind of like coming out of startup mode and becoming public real company mode. And so it's dealing with that more rapid growth, expansion, shipping more and more products, and trying to be able to stay on top of machine reliability and performance. And when you're a smaller company, you have the ability, and it's also a requirement, I think, you kind of live and die by your reputation, right? So you have these people that can kind of be one-offs and go help all the people that have your machines. You can be there all the time and, kind of usher them through the process. And as we scale and grow, you very quickly realize that's not scalable, right? So you have to then turn your focus very much on reliability and how do we make these machines behave like a CNC, where it's kind of set it, forget it, let it go. And I think the difference is that these additive machines, at least on the metal side, they're very finicky. Optics are very finicky and very susceptible to things like temperature changes and those types of things. So being able to understand your failure modes, which some of that only comes from scaling and having a large number in the fleet, and then being able to go and address those.
Really, the shift from making machines for prototyping to making machines for production means you have to pay attention to those things. So, very, similar area in the metal. What about you guys? What's your?
Yeah, sure. I was racking my brain because I agree with Matt. There's a lot to choose from on the difficult road to production. But I actually think probably one of the biggest things that we struggle with even today is convincing people it's real. There's been so many hype cycles in 3D printing over the years. In 2012, 2013 was a hype cycle where I got pulled into the industry because I got so excited about what people were saying. And I think that's an important message for the audience too. Those of you who have been around have seen a number of hype cycles, and how do you figure out, is it really happening this time or is it just more hype? Because there's a lot of talk in the industry about what's actually happening. And I think we're on the precipice of a big breakthrough with a lot of different companies in the ecosystem that are kind of all coming up at the same time. We specialize in stainless steel today, but metal parts of softball size or smaller. And that's one small piece of the ecosystem. To your point, there's going to be a lot of different players in composites or metals or across the whole spectrum. And you got to figure out what's real. And I think it's happening now. And it's happening now in a small way, and it's happening now in a way that's kind of hard to see. But there are a lot of companies with a lot of funding putting a lot of money into quality, into repeatability, to make sure that it's actually there. And I think the people who are taking advantage of that right now are going to have a big competitive advantage in the next decade because you'll be ahead of the curve. So we have a lot of customers who basically say BS. I've heard this story before. And fortunately, we're a parts supplier, so we ship first articles, not machines. So I don't need to convince them to spend $2 million on a machine. I just need to convince them to at least just accept a package delivery. So what's nice about Additive is we don't have huge setup costs, and there's not a big upfront expense. So I can ship you 5 first articles to kind of prove it, to put my money where my mouth is, and to show you it is real as we kind of scale up. So I think that's kind of the biggest pushback we get from the market.
And my biggest indicator, if we're in a hype cycle, is if my 82-year-old aunt in Fresno sends me an article about it. I know, or that it's hype. But 2 to 3 years later, it's going to happen, right? So, in fact, building was one she sent me probably 6-7 years ago, and now it's happening. So, go ahead.
Just to add to that real quick, the hype for sure, but I think even one step further, there's a lot of people out there in the industry who've been burned by Additive, and like they bought into the hype. They went all in on it, and like you said, the parts sucked, right? Yeah. So it's you're kind of starting in negative territory with some of these customers who have that bad experience and trying to, just claw back to zero, really.
Yeah, I got to get that reputation back. Sam, speaking of buildings, what was your biggest challenge you guys faced?
Yeah, so I mean, the two biggest are, as Matt has mentioned here, it's industry resistance. But it's different in the construction space because the construction industry is naturally resistant to new technology and to change. I mean, and there are good reasons for that. I mean, the sad reality is that the building codes are written in blood. They exist because things have gone wrong. And we also live in an incredibly litigious society. So if you build a house, you will get sued. And so they're very, very, very risk averse. So that's one of the big challenges. Thankfully, we've found a couple developers who we're working with. We've got 2 projects going. I've already broken ground on one down here in Southern California. It'll be the world's first 3D printed zero net energy communities, which we're really excited about. And we anticipate once those are on the ground and we've kind of demonstrated we can do things at scale. I mean, between the 2 of them, we're looking at 100 plus units. That we're going to see a lot more interest from the industry because they're always waiting for someone to do it first. Because we get a lot of, we're really interested. We're not going to be the first mover though, particularly among the bigger players. So that's been a big one. And hand in hand with that is the regulatory side of things. And so that's where we've actually taken a very proactive approach. Because again, going back to the realities of the building code, it's very you have to be able to convince a building official that it's safe and then it actually does what it needs to do and it meets all these codes. So that's why we very early on, 3 years before we were ever going to produce anything, started working with UL, started working with California's Housing and Community Development Department, their factory built housing program. Also, we do work with ASTM. So we've been really proactive in engaging with the regulatory environment and leveraging it to our benefit. That's how we came about by creating 3401 because no one had ever evaluated anything like what we're doing for that use case before because it hadn't existed before. And so it's really how do we, and I mean, again, we're not even we won't be 5 years old till August. So we're babies here. But in that time, we've created the first standards for 3D print construction. We've delivered the first homes in California with 3D print construction. We're developing the first. So we find that even though it's often when you're startups like, oh, regulations are terrible. It's like, actually, no, they're amazing if you know how to work with them. And if you know how to engage with the public sector. And so that's where my having a background with an MBA and an MPA has come in very handy by being able to understand where they're coming from, be able to speak their language. But those have been 2 of the biggest challenges. Technically, there's been tons of challenges too, but I've got amazing teams.
Great.
They've done a great job of solving them very quickly.
What's the biggest challenge? Let's just focus on the new powder bed system at Stratasys.
Yeah, I look at adoption. If you say what's the challenge to production, right? First of all, it's performance. So people want their parts to perform like they're familiar with, going back to familiarity. We're not there. We're not like an injection mold. Most additive is not in a polymer area. Some gets really close. Some have some weaknesses if you want to directly compare. I suggest stop directly comparing and learn how to look for the opportunity.
Yeah.
The next thing is, so you have performance, you have economics. Does it, if you look at the replacing of tooling, if you will, or augmenting tooling, I don't promote that we're going to replace tooling in a world. Tooling will have a spot, additive has a spot, et cetera. But now it's economics. Does it work? Can I pay X for what I want and make profit on that over the lifetime of the product, et cetera? And then the thing that I find for additive in general, but I'll move to what we did in powder bed at Stratasys, and that's confidence. People need confidence. Then the other things, like show me somebody who did something like what I'm doing so I don't have to be the frontiersman. Let me see an application story, a success story. Let me look and see what others did and gain that confidence. But then what Stratasys has to do for confidence is prove that we can talk the manufacturing language. We're starting to look at things like OEE, right, for machine performance. We're looking at things like variability. I think you mentioned it, machine to machine or machine within the machine, right? Build to build, machine to machine, location to location. So when we do our very first data spec sheet on mechanical properties for SAF produced parts, which is our powder bed, we didn't just publish means for the data, we published the standard deviation, which is a bit new for additive because it's not easy to do. But even if you don't like the number, and actually the number's pretty good, to be honest, if you compare to additive in general, our number's good. If you compare to a CNC, it's probably nowhere near the same number. But there are applications that work at that number. Our job is to find them and help people see where they can employ it and get past the noise of the hype. When people said, I can do everything, you believe it, you buy, you fail, you have a 10-year wish not to get back into it, right? So we want to give them the confidence, and then as sellers, I consider myself a seller, even though it's not really my role. I'm trying to be a consultant to help people find where they can be successful, set the expectations right, and get an economic win, get a performance win. We have to get that consistency and build confidence that this really works.
Really good point. And of interest is none of you brought up the technical challenges. These are all human challenges, right? These are all convincing people, processes, systems. I think that's really encouraging that we're there, right? We're past the technical challenges can be met. We're to the point of dealing with humans, which is more of a struggle, but we'll get there. We'll get there. So we've got about just a few minutes before I'll open it up for questions. And I put this on the list to kind of start a debate. And people, maybe at AMUG, after a few too many beers, may have gotten into fights about this. What do you feel for production is, and we've already heard what Sam's position is, are we going to be seeing distributed or centralized use of additive manufacturing 10 years down the road when it's more common in production? And I'll just throw it open to whoever wants to put a stake in the ground on that.
Yes.
Both.
I think it's really going to come down. It's going to come down to it's going to come down to application. Like for us, it makes a lot of sense to. This is something Matt and I were talking about yesterday, actually, after his talk. Is like with us, it makes a lot of sense to have a distributed production because it makes sense to be located near where the house is going to be. There's cost savings, there's logistics savings, there's carbon savings. But like with what Matt's doing, and I would love for him to talk a bit about that. Doesn't make sense to have a bunch of them. It makes more sense to have centralized because you can just ship them. And so it's going to come down to what's the role, and that's also again like Tim was saying with it, where are you going to use injection molding, where are you going to use tooling, where are you going to use additive. So it's at the end of the day, as the answer with everything is, it depends. But that said, within that, there's fascinating possibilities.
You used a key word a minute ago, which was economics. I think it comes down to economics, even more than sustainability, unfortunately. But when we're talking production, we're talking economics. And if you're making small parts, like in a flat rate $40 UPS box, I can ship 10,000 parts. Then it's not worth setting up a factory, co-located with a customer, when you look at everything required to get to production. So for us, I think within a country, it probably makes sense to have a factory. You might have diversification from us, geographical diversification just due to a procurement requirement for reducing risk on production. But beyond that, yeah, a factory makes sense for us. But I'm sure building buildings it's hard to ship a building. So
I mean, we've shipped from California to Florida, so it's doable. But yeah, no, it adds cost, it adds expense, and it also it means we're shipping California construction costs into places that might have much lower cost structures. So again, as you say, it comes down to economics.
Yeah, I think to your point, it's going to be both. And a lot of it depends on the landscape of the customer, right? If you've got, like, for example, we do a lot of work with oil and gas, and you just think about locations of oil and gas and where the parts are needed, right? They're not centrally located. They're spread across the world in extremely remote areas. But do you want a $2 million machine set up in the North Sea? Probably not. Something we're seeing with our technology, at least in particular, is, and I think it'll grow, is having a couple of, I'll say, development machines at a centrally located kind of technical center, if you will, and assuming this is all within a single company, where they can vet out their components, prove out the prints, the parts, the designs, and then once they're ready to go, just send the file out to where that needs to be printed, right? And so we've got customers doing that today, and for a multitude of reasons, but primarily because they've exceeded the capacity that they have internally and need additional capacity, so they have leveraged our contract manufacturing network to bring in additional capacity. And just having the ability to send the file, say, here's the part I need print, go print it on your machine, and knowing that they'll get the same part back out enables them to be able to do that. Whether that's a long-term goal for them, I'm not sure. I think they do still want to bring that in-house and kind of own that part of their manufacturing supply chain. But the opportunity is there for other people who don't necessarily want to make the investment in the machine, and they can just utilize this network of manufacturers who have the technology and also have the secondary processing, the machining, the heat treating, the surface finishing, because that still exists, right? And that's needed in many applications.
What about polymers?
So I'm going to chime in because that's what I do. So, local versus distributed. I think a lot of us who've been in the additive business have dreamt and participated in the concept of distributed. And I believe in that. And I think that's where we got to go. But one of the things that a lot of people in additive, especially if you're, an OEM, you think about is, I have the device. My device is going to make this happen. Well, it's not. Our printer doesn't print product. It prints an end-use part. But just like an injection molding machine, you have to do something with that part at the end. So if you're going to talk about distributed, Stratasys as an OEM of different additive technologies can participate in an enabling device to make distributed. And it's great that we're looking at variability from build to build, location to location, machine to machine. That'll help that. So, for example, now I don't need a centralized tool somewhere. Okay, great. But I'm still not printing a product. I'm printing a part. So where I start to get excited is I look at a lot of the technologies that are going on, whether it's MES or it's in robotics or whatever. There's a lot more stuff that has to happen end to end to get to distributed. And that's where I see a lot of excitement. Yes, we want to, have something at the core of that as a 3D printer, but you're going to need finishing devices. You need to get a finish that you want. You need some automation. Not everything should be automated, by the way. Some things should, some things probably better done by humans. We have a shrinking workforce right now, or have had in the last 2 years. So we shouldn't maybe automate everything, but we can automate to the point where we're smart and create high value jobs, and that starts to become distributed. And I think people are, maybe there's going to be, the office service center, and who the office service centers are in different cities. There's going to be maybe a new breed of contract manufacturer who's kind of like what we used to call the service bureau of the additive business, and a combination to a bigger contract manufacturer. They just won't be the top three that you're familiar with today. And maybe they'll be the distributed, and they will set up little cells within major population areas. And once we can be transportable with our data, get transportable results, and have the formula how to go end to end, that's when we get the holy grail of localized production.
Yeah, that idea of a cell that does the whole thing is critical. And some of you have been in the industry for a while, remember the hype cycle around the 3D printed car, and I can talk about them now because they're out of business, but Local Motors really pushed this idea of a truck that had a factory in the back that you could put anywhere and make the car right next to a person. And I think what was missing from that was, yeah, you can make the frame, but there's a lot more that needs to be done. Yeah. So true, so true. All right, well, I'm going to open it up to questions to the audience. I've got more here if you don't, but we'll go ahead and start in the front row.
Just to follow up on that, you're starting to talk about
Sure. Yeah. So, I mean, that's what we're doing today. We've got what we call a network of contract manufacturers who are primarily, first and foremost, machine shops. And they are very good at creating your traditional type of component. So they have all the certifications and compliances for things like ITAR and stuff like that. And so they add additive to their capabilities, and it's a very nice, I'll say, marriage of the technologies, because like we know, additive parts don't come off the printer typically as an end use ready to go part, right? You need machining, you need surface finishing, heat treating, whatever it may be. So many of the customers that come to us, and when I say customers, people looking for parts off of our technology, want that end-to-end solution, that turnkey product. And just having a printer doesn't necessarily give you that, but having a contract manufacturer that has a printer can deliver that for you.
Maybe I'll jump in here because you're actually hitting on what is our vision for our company. We really envision 3DO as a modular manufacturing platform, which in the long term, I think becomes similar to today's tier one supplier that has a lot of different capabilities, capable of doing much more than just parts, capable of making products. And so over time, additive is one piece of the puzzle, subtractive is another piece of the puzzle. And as you bolt on every different type of next generation technology, whether it's laser sintering, whether it's polymers and metals, it becomes really interesting to think, what can a digital factory do in this next generation that was just impossible to do in a previous generation? I think you can do products in a much smaller form factor with much more capability, ultimately delivering a lot of value that has been promised in 3D printing, such as new designs that just weren't possible. Speed to market, not years, but getting products to market in months instead. And with the next generation of additive technologies, hopefully doing that at a cost that is close enough to conventional manufacturing that a customer says, I'd rather launch 3 products a year and pay a little bit more for those products than to launch 1 product every 3 years and save 20% on the BOM. So I think you're hitting on what is the future of manufacturing, in my opinion.
Yeah, a lot of the maintenance companies, for example, sell uptime as opposed to personnel or product.
Selling solutions or selling time or less risk or value. Yeah, ultimately value, right?
Yeah.
And that's why I personally think that there's going to be a resurgence of something that happened in the early days of additive in general. When it was called rapid prototyping is when a lot of the service bureaus that we've come to love now, right? They started with stereolithography in the early 90s and through acquisitions became pretty large, well-known names. But I think there's an opportunity for another breed of entrepreneurship to come do a little bit of what I was talking about before, like maybe a manufacturing cell. But then I think about a supplier, let's say somebody who's in business today, not so small, and I can't imagine the volumes they do in a year, but let's say they contract manufacture for different industries. And something I've heard way more than once is that they do not accept bids to do jobs less than X, 100,000 pieces in a run. Why? Because they do cut tools and stuff, and their profitability is not there. But when you change the economics and you don't have to do the tool, then you can have a more rapid, okay, this sounds like rapid prototyping, but your design and your product lifecycle shortens at the beginning now. And not only that, but your cost basis is shortening. So all of a sudden, somebody who's willing to go, maybe who they're traditionally manufacturing, cutting a tool, no bidding under 100K, all of a sudden, if they embrace some of the projects they could do with additive and put the workflow end to end, and they have that confidence, they can actually start taking jobs for under $100,000 and not take a margin hit. They can actually be very profitable. And I think if you take your way forward machine and think 40 years from now, right? You think what's going to happen is all product life cycles are going to be under 100,000, and they're going to last 6 months. And we want immediate new stuff. And when we give them that capability, that's going to happen. That's where we're going to evolve to.
And I think just to add to that, so I think that's the first step, right? Of like bringing the economics down to where it makes sense. I think where it gets really interesting is when that paradigm shift happens and people start to use additive and its true capabilities to do things that are not comparable to traditional manufacturing, right? Which is still, I think, fairly new in the design world. There's people like the SpaceXs of the world who are really pushing it, but the larger, more traditional OEMs they still want that, parallel path. It needs to be traditional, but maybe we'll look at additive too. So it's like once you get them in, that additive can compete maybe on a traditional design sense, and then they can think one step further. What can I really do? What does this product really want to do in terms of function and performance and things like that, and truly design for what this manufacturing technique is capable of doing?
A really good point. Really good point. Yeah, question.
Oh, okay. It's already happening. But, there's so many examples out there, like you bring up one, right, that we're aware of, but there are so many things we're not aware of that are happening. So it's not really a matter of that. It's when will it happen over here? When will it happen over here? So I think so. And by the way, one of the things, a comment was made here when you think about a few of the things I've said, and I thought about the economics. So one thing additive does, and we used to say this, complexity is free. Yes, it's free. If you can trust the parts for what they're supposed to do, it's free. But you can do cool stuff. So you can do simple stuff, and if the economics work, I can make a nut, I can make a bolt, whatever. I don't need it to be complex for it to actually stack up. That's the beauty of this. Once people start trusting it, they won't just look for an undercut that's impossible with an injection mold. They'll just look for anything. Going to your point on a gear shift, some people think of a conductive thing, but what went through my mind immediately was a structure where air is passing through. The knob does not have to be solid. It could actually be a mesh. And the mesh will keep you cool without a conductive, because you could have air flowing through, and when your skin hits, the heat won't be pent up in the plastic. So there's so many different ways to look at this, but it's happening now. It already is.
And I think one interesting comment that you made was the comment of maybe we can do this with additive now. I think it's no different than like an injection molding versus a casting versus a forging. Those all have their unique set of applications that make sense for that manufacturing technique. I think right now additive is looked at as like an alternative to all these other ones. So it's like this or additive. It gets really interesting when people start to say, this is the only thing we can do with, like additive is the only thing we can use to make this, not can we make it with additive. Does that make sense?
And I think playing off of that, it is happening now, and the vast majority of first orders, first parts we work on with the customer are parts that have been designed for traditional. So they're just bidding it out. They're saying, I can go a CNC at $8 a piece. If you can beat that, then we'll do some business together. After the customer gets to know us, sees that we can ship parts on time, gets a little bit of trust, then we're kind of pulled into the inner circle and we get to help with design. And we get to help kind of adding undercuts and things that can't be made any other way. So it gets pretty interesting. And P.S., I didn't know hot shifters were such a problem.
We did one. We first got our concept laser machine. One of our guys is a Subaru guy, and I guess Subaru people like trick out their cars. So he designed and 3D printed a metal knob, and this is in Phoenix, and he burned his hand on it. Wow. So we redesigned it with a mesh. That was our solution to it. We redesigned it with a mesh, and yeah, it was a great experiment, and we use it a lot as a case study to design for additive. I think is what's missing in a lot of cases. You're right. People come to us all the time, to our service bureau, with, I injection molding this part. Can you make it? And we're like, well, let's redesign it and take advantage of the technology.
I think one of the dreams of the automotive industry is spare parts. Now, this could be even maybe one of the more compelling stories eventually for localized production of some sort. Maybe Pep Boys has a 3D printer. If you could 3D print the object, there's a lot more to it than that, right? If you need an alternator, it's wiring and all that stuff. But automotive is they've been looking at it for a long time. Why? Because where did I store my tool? Or how much did it cost me to store that tool? And all of a sudden, a car that's 30 years old is unserviceable. But they want to be able to service those vehicles, whether it's the OEMs or aftermarket, extend the life and all that. Now, the problem today is that you don't have a good tracking mechanism, although there's a lot of good softwares that have evolved since this dream began. And there's a lot of other problems in that people want to start servicing equipment that was built in the 60s, but it was designed with other manufacturing in mind. So what we try to do is fit a little bit of a square peg in a round hole by saying, can I take an existing design that was done 40 years, 50 years ago, and find a way to 3D print it so I don't have to locate the tool or make another tool? All right. That's one challenge. So we can figure that out through simulating, maybe changing the design enough to make the properties what it needs to be. But now, again, think about the 40 years in the future. What's the trajectory? The trajectory is make those parts as additive from the beginning. And then 40 years from now, that dream works.
Back corner. Got 2 minutes. I'll start here and we'll go down the line.
For us, it is relatively small, like softball size part or smaller, and relatively complex. If it's like one setup on a CNC to machine it, we'll never be cost competitive enough to take that on. But if it's 2 setups or 3 setups especially, then economics can work out. So small and complex for us.
Ours are actually, if I just focus on the powder bed fusion, it's not a huge build volume, so it can't be huge parts either. But as parts can be scaled and we can build multiples within that volume, they actually start to compete with some injection molding at some volume, which is very new for us. And it's out there. So it's a sweet spot. It's hard to describe. We ask a lot of questions as salespeople to try to figure out where that is. So.
For us, it's definitely not small. It's definitely large scale. I think one of the real sweet spots is that ability to have a wall panel that replaces 8 to 12 layers. that wouldn't otherwise be in there. So it serves as your air barrier, water barrier, vapor barrier, fire, thermal, all of that, all in one. So that's really one of the advantages that we're able to bring right now. And I think that's where one of the sweet spots of 3D printing in construction is, with different materials, the different realities around that, just based on the code. But a lot of what we're talking about also comes down to what are the regulations, what are the standards, how do we work with them, how do we demonstrate that, and it's getting those in place and being able to do that that's, I think, really going to accelerate that shift.
And for us, it's kind of similar complex components. And what we typically say is components that are handling fluids, transferring heat, dealing with aerodynamic type structures. But I think that's changing. I think it's coming down. The economics are starting to flip a little bit as you see these more productive machines, faster machines, and you're starting to see more of the like distributed manufacturing maybe starts to make some more sense, or you get the quality piece out of it, and maybe that's the incentive for using additive versus maybe a complex traditional machining or something like that.
Well, that unfortunately is time, and I think we could talk a lot more about this, and we're headed into a break for 15 minutes. We'll be back here at 9:45 to talk about how standard configurable automation is changing the game. So think adult Lego, and that's from ATS Life Sciences. So we hope you come back for that. Our panelists will be around. Please do engage with them and myself if you have any questions or comments. And hopefully this has helped you think about production. And for me, my big takeaway is I got to stop thinking what I learned in my manufacturing 103 class in 1985. There's other ways to design and build things. Yeah. All right, thanks. We'll be back in 15.